Now that we know how to actually construct a box plot, let's look at how we would interpret the box plot. Remember that our box itself in the box plot, this blue box that we're seeing here, is constructed by finding Q1 for the left edge, Q3 for the right edge, and the median is in the middle. We also know that the Q1 to Q3 range is considered the IQR, or the middle 50% of the data. Another characteristic that we see here on our box plot are the outliers that we can clearly identify because they are falling outside of our fence. So this would be considered our upper fence edge here, and these points that are outside of that upper fence would be considered outliers. So the first thing that I want to be able to identify using a box plot is, are there any outliers? Remember that outliers can occur by chance. They might be some sort of data entry error or measurement error like we saw in our height example previously, or it just might be the actual values in the data set. If you think back to our examples that we shared for professional football players, there were very large values that fell outside that would show up as outliers because they're such large values within that sports team, but that doesn't mean that those numbers aren't truly a part of that data set. Another thing that we start to see when we're looking at a box plot is I can see from the box plot and estimate what the histogram would look like for this exact same data set. So I'm going to overlay it here with the actual histogram of the same data set. If we were to describe the shape of the histogram, we would say that this histogram is considered skewed right. So the majority of my data is over here in the left main hump, if you will, of our sketch, and then we have values here out in the tails. Now, how does that relate to our box plot image from below? When you're looking at your box plot, you want to focus on two things, I would say, to try to understand shape. First of all, where is the box itself located in relation to these whiskers or lines? Notice that the box is shifted to the left. In other words, the leftmost line that we see here is shorter than the rightmost line that we see there. So that's the first one. The box itself is shifted to the left because we have a shorter line on the left and a longer line on the right. The other aspect of this we want to indicate is, where is the median in relation to the edge? Notice that the median is shifted farther to the left as well. So when the median is shifted farther to the left and the box itself is shifted farther to the left, that's going to imply that pretty much the majority of my data is over here on the left, making anything that's occurring on the right look kind of like this skewed right distribution up there, right? So remember that all the way up to Q3 here, that's going to be 75% of my data is shifted over here to the left. That leaves a small amount of data over here, which is really spread out, or 25% of the data. And so I can make that relationship between a box plot and understand what the histogram would look like. Let's practice that again on the next screen. Here I have another box plot where we're showing pulse rates. And notice, again, if I want to understand what the histogram, or if I can estimate what the histogram is going to look like. Here, the box itself is located roughly in the center of these two lines. So the line to the left and the line to the right are roughly equal. Also, let's look at where the median falls within these two lines within the box. So where does the median fall within the box? It looks to me like the median is falling directly in the middle of the box. So I have 50% of my data occurring pretty much in the middle of everything, and then we have data occurring out here on the two tails. This would imply then some sort of a normal distribution where you have the majority of your data occurring towards the center, and then you have less data out in the tails. So our box plot and our histogram are actually telling us the same thing. They should be reinforcing the same image of our, if we're trying to interpret one over the other.